Hi everyone. In today's video, we are going to discuss this example. Okay. So actually this differential equation is of type reducible to exact differential equation. Before that, we will revise few concepts of exact differential equation and we will see how to solve such problems. Okay. See, when we can say the given differential equation is exact, if you have differential equation like this, m dx plus n dy is equal to 0, where m and n, these are functions of x and y, like this. Multiple of dx is m, multiple of dy is n. So see, when we can say it is exact, if dabba m by dabba y is equal to dabba n by dabba x, it means the partial derivative of m with respect to y is same as partial derivative of n with respect to x. Then we say the given differential equation is exact. If it is exact, it is very easy to solve the problem. But see, if it is non-exact, then first of all, we need to convert it into exact differential equation and then we have to find its answer. So we have this given differential equation. Let us check whether it is exact or not. So let me note down m and n first. Okay, m means multiple of dx, which is x raised to 4 plus y raised to 4, n multiple of dy. I should consider the minus sign also, minus xy cube. Okay, so let us find these partial derivatives and let us check whether those are same or not. Dabba m by dabba y. Okay, let us find the partial derivative. M x raised to 4 plus y raised to 4. You can see addition is there. We can take separate derivatives. Derivative of x raised to 4 plus derivative of y raised to 4. Okay, we are differentiating with respect to y, so that's why x raised to 4 is constant. That means any function of x is constant and derivative of constant is 0. Its derivative will be 0. Now we have to find derivative of y raised to 4 with respect to y. So this formula we use here. Okay, derivative of x raised to n is n x raised to n minus 1. It means the formula says whatever the power, we write it first and we reduce it by 1. The power is 4. So let me write 4 here. We reduce it by 1. 4 minus 1, 3. So that means the derivative is 4y cube. In this way, I got this first partial derivative. Let us find the second one also. Now, dabba n by dabba x. Okay, what is my n? That one. So I should consider minus xy cube. See, whatever the constants, we will take them outside first. Minus 1, that minus sign will come outside, as well as we are differentiating with respect to x. Y cube is constant, so I will take it outside. We have derivative of x only. Derivative of x with respect to x, it is 1. So minus y cube into 1, which is minus y cube. See the first partial derivative, that means dabba m by dabba y, 4y cube. Dabba n by dabba x minus y cube. That means both of them are different. That means given differential equation is non-exact. Let me clearly mention here. Okay, just a minute. Therefore, dabba m by dabba y is not equal to dabba n by dabba x. Therefore, given differential equation is non-exact. Okay, it is non-exact. See, it is non-exact. That means first of all, we have to convert it into exact differential equation. Now the question is how we can convert it. Okay, so there are see, we have to find integrating factor and there are 4 different rules of finding integrating factor. We have to check which rule is applicable and we have to use that rule to find integrating factor. So let us check, let us see which are the rules we have. The first rule is dabba m by dabba y minus dabba n by dabba x upon n. Okay, so what we do, we find its value. Difference in these two partial derivatives, dabba m by dabba y and dabba n by dabba x divided by n. If it is function of x only, in that case, the integrating factor is e raised to integration f of x dx. See, here we should have the function of x only. It means there should not be any y. Second rule, if value of this del by n by del by x minus del by n by del by y upon m is function of y, we want just function of y only, there should not be any x. In that case, integrating factor will be e raised to integration f of y dy. Okay, if this condition satisfied, then only I can go for that rule. Otherwise, that means if you are getting some function of x also, then I cannot go for rule number 2. Or if in this case, okay, if you get the function of y also there, okay, in right hand side, then you cannot go for rule number 1. Two more rules are there. The rule number 3 is given differential equation should be in this form. Okay, that means whatever I am writing. Okay, so that means y outside f1 of xy, some function of xy, okay, both should appear simultaneously, sin xy, e raised to xy, everywhere, x square, y square, like that. In the second term also, x outside and some other function of xy, f2 of xy. In that case only we can go for rule number 3. And rule number 4 is given differential equation should be homogeneous. Okay, the given differential equation should be homogeneous. Getting homogeneous, that means power of each term must be same. So see, we will check which rule is applicable, and according to that we will find the integrating factor. I suggest you to go for rule number 4 first. If it doesn't work, then go for rule number 3. If both of them will not work, then only go for rule number 1 and 2, since they will take some time to find integrating factor. It's not an easy task as compared to 3 and 4. Simply you have to check the function is homogeneous or not. You can easily check just by observing the equation. Let us check this one is homogeneous or not. What is power of x? 4. Power of y? 4. See, let us discuss the power of this term. Power of x, nothing is there, that means 1, and power of y is 3. So 3 plus 1, 4. It means power of each term is 4. It means the homogeneous function. This is homogeneous function. So obviously I will go for rule number 4. So let me clearly mention, given differential equation is homogeneous. Okay, but see, wait, this is not the only condition it should satisfy. There is one more condition. If that will also satisfy, then only I will go for rule number 4. The second condition is mx plus ny should be non-zero. That is the second condition. Then only I can go for rule number 4. Let us find m. Where is my m? This is my m. X raised to 4 plus y raised to 4. We are multiplying by x. N is minus xy cube into this y. Okay. So x raised to 4 into x raised to 5 plus xy raised to 4 minus xy cube into y raised to 4. Tell me, can I cancel anything? Definitely. These two terms will get cancelled and we will have x raised to 5. Okay, whatever we get doesn't matter, but it is non-zero. That is the most important thing for us. If it is non-zero, then only rule number 4 is applicable. It is homogeneous, it is non-zero, mx plus ny. That's why rule number 4 is applicable. And that rule says the integrating factor is 1 upon mx plus ny. Right? That means 1 upon mx plus ny. We have calculated its value is x raised to 5. So 1 upon x raised to 5 is integrating factor. That means if you multiply given differential equation, this one, by this 1 upon x raised to 5, then this non-exact differential equation will be converted into exact differential equation. Okay, so let me do that thing. See, I want some space to write. Let me remove this part so we will get some free space. Okay, just a minute. Okay, so let me write it here. Multiplying, I should write everything properly. Multiplying given differential equation by 1 upon x raised to 5. So let us see what will happen. Two terms are there. I will multiply each term by x raised to 1 upon x raised to 5. See, it is in denominator. So when you multiply, obviously it will appear in denominator. Zero. If you multiply 0 by this 1 upon x raised to 5, you will get 0. Okay. So what will I do after that? I will divide separately. So it will make the problem simple. So let us divide separately x raised to 4 by x raised to 5 plus y raised to 4 by x raised to 5 dx. See what will happen here? 1x we can easily cancel, right? So what will I get? Minus y cube upon x raised to 4, since we have cancelled out 1x, dy is equal to 0. So here also x raised to 4 will get cancelled, am I right? So 1 upon x plus y raised to 4 upon x raised to 5 dx minus y cube upon x raised to 4 dy is equal to 0. That means this is exact differential equation. We multiplied the given differential equation by this integrating factor. So we get exact differential equation. This is an exact differential equation. Okay. So let me note down our new m, multiple of dx. That is our new m. Okay. And let me note down our new n, the multiple of dy. I should consider this minus sign also. So I got m and n. So after that, we have to find the solution of this exact differential equation. The solution is, let me write here, solution is integration m dx treating y constant plus n free from x dy is equal to c. So when you have exact differential equation, its solution is fixed. This is the solution. That means simply the addition of these two integrals. So what will I do? I will solve these two integrations separately. We will find their values and at the end we will put it here and we will get the answer. Okay. So there is no more space to write. Make a screenshot of it first, then I will move further. So I think this much space is enough to solve the to complete this problem, right? Okay. So let us consider the first integral. So integration m treating y constant with respect to dx. Okay, so let me write integration. What is my m? This is my m. 1 by x plus y raised to 4 by x raised to 5 dx. Okay, as you can see, addition is there. So I can take the separate integration. So integration 1 by x dx plus integration y raised to 4 by x raised to 5 dx, right? So you know the integration of 1 by x, it is log x. Integration of 1 by x is log x. So let us talk about this. We have already mentioned y is constant. That means that y raised to 4 is constant. You can take it outside. So y raised to 4 coming outside and we are getting 1 upon x raised to 5. Okay. But see, what will I do? I will shift this x raised to 5 to the numerator. It means we will have x raised to minus 5 dx. Getting the point? Okay, so now how to find the integration of this one? We have very simple formula. Integration of x raised to n is x raised to n plus 1 upon n plus 1. That means what we do, whatever the power, we add 1 in power and the same number in denominator. So it means value will be log x plus y raised to 4. We are adding 1 here. So minus 4 upon minus 4. Okay, so let me write in a proper way. Log x plus minus minus y raised to 4. See, it has minus sign. 4 I am writing in denominator. It has minus sign. So what will I do? I will shift to the denominator. So the power will be plus. Shifting to the denominator. So x raised to 4. That's it. So this is a required answer. Getting required answer, that means value of this integral only. So let us talk about the second integral. Now, integration. So let me write terms in n free from x dy. Getting? So we have to find out the terms of n which are free from x. That means there should not be any x. Let us check how many terms are there in n. Only one term is there. You can see only one term is there and having x. So you cannot take that term. It means 0 dy I should write, and integration of 0 is 0. So let me write the solution. So solution that means simply addition of these two integrations. Okay, the value of first integral is log x minus y raised to 4 upon 4x raised to 4. Value of second integration is 0, no need to write. If you want, you can write plus 0, but no need to write, is equal to c. This is the final answer, right? So this is required solution of given problem. So after that, what will I do? I'm going to give you one problem for practice. Okay, just by looking this problem, or in previous, see in this playlist already plenty of problems we have already solved, getting, so you can go through it and you can try to solve one problem on your own. If you get the answer, okay, you can tell to me, or in next video I'm going to cover the solution of that problem. You can cross check, or if you have any difficulty, definitely you can watch my next video in which you will get the answer. Okay, just note down this solution and then I will give you the next problem. So this is practice problem for you. Okay, try to solve this problem on your own. Otherwise you will get its answer in my next video. Thank you. See you in next video.